A 12-meter 200 Newton uniform ladder rests against a frictionless wall, making an angle of 60 degrees with the horizontal. If a 600 Newton H. Jang dog is on the verge of slipping to her unnatural death at 5 meters up, what is the coefficient of static friction between ladder and ground? Step 1. List known information. We know that the weight of the ladder is 200 newtons, the weight of H. Jang dog is 600 newtons, the length of the ladder is 12 meters, the angle is 60 degrees, and H. Jang dog is 5 meters up the ladder. The second step is setting up all the equations needed to solve for the coefficient of friction. We don't have to worry about the frictional force because it's acting from the pivot point, so the distance is 0. We can first set torque to 0 to find the force of work done on the ladder by the wall. Then we know that the force of work equals the force of friction because those are the only two horizontal forces in the system and are opposite to each other. Then we can find the normal force by setting the y component of force to 0, so normal force is equal to the sum of the two downward forces of the ladder and H. Jang dog. The last equation is force of friction is equal to mu times normal force, and we can derive an equation for mu to solve for the coefficient of friction. First, let's solve for the force of work done on the ladder by the wall. Set the torque equal to 0, and since torque is equal to sum of all the force times perpendicular distances to pivot point, we can make the first equation. Force of work times L sine theta, which is the horizontal distance from the wall to the pivot point, minus first mg times half the length of the ladder cosine theta, because since this is a uniform ladder, we measure the distance from the center of mass, which is half the ladder, minus second mg, times the horizontal distance from the second mg to the pivot point. Then we plug the numbers in. The length of the ladder is 12 meters and the angle is 60 degrees. The ladder is 200 newtons from center of mass and H. Jang dog is 600 newtons. After simplifying and solving, we get force of work equals 202.07 newtons. Next, we solve for the force of friction. Since we know that the x component of the sum of forces has to be 0 because the system is at rest, we can set force of work equal to force of friction. So force of friction is also 202.07 newtons. Then we solve for the normal force exerted by the ground on the ladder. We know that the y component of the sum of forces must also be 0, so we can set normal force equal to the sum of the two downward forces of the ladder and H. Jang dog. We add 200 and 600 and get normal forces equal to 800 newtons. Finally, to get the coefficient of friction, we can derive the formula for mu by dividing the formula of friction by normal force. To get mu is equal to force of friction divided by normal force. We know that force of friction is 202.07 and normal force is 800, and when we divide that we get 0.252 as the coefficient of friction. Goodbye children, H. Jang dog signing off. Peace.